Have you ever stopped to think about the actual magic happening inside your smartphone, or your smartwatch, or even in the super complex systems in a modern car? Well, there's this incredible, almost invisible layer of engineering that makes it all tick. So today, let's dive into that hidden world. It all boils down to a question you've probably asked yourself a million times while holding some sleek new gadget. Just how do they do that? Seriously, how do they cram so much power into something that can slide into your pocket or, wrap right around your wrist? Okay, so the first part of the answer is, well, it's pretty intuitive. As our devices shrink, the electronics inside have to shrink with them. It's a no-brainer. Everything just has to get smaller, more compact, and way more densely packed together. But here's the thing, just shrinking everything isn't going to cut it anymore. Not even close. Modern design is all about curves and these really cool unconventional shapes. So the circuits, they can't just be tiny. They've got to be able to bend around corners to squeeze into spaces that a flat, rigid board could never, ever dream of fitting into. And then you've got the final boss, folding. I mean, to create something like a foldable phone or these incredibly compact medical devices, the circuitry itself has to fold in half without snapping. This changes everything. It requires a totally different way of thinking about how we build electronics. So how in the world do engineers solve this insane puzzle of shrinking, bending, and folding? Well, they use this truly remarkable piece of technology. Say hello to the bendable circuit. Okay, its official name is a flexible printed circuit board, or what everyone calls a flex PCB. And its superpower? It's right there in the name. It can bend and flex. And that one simple capability, believe it or not, is the key that unlocks the design for so many of the devices we use every day. Let's put it this way. For decades, right, electronics were built on those stiff green boards you've probably seen. They're like these little city grids, super powerful, but totally flat and unyielding. Flex PCBs, they're more like a city map that's been printed on a piece of fabric. They've got all the same complex info, but you can fold them up and stuff them into any shape you want. And as you can probably guess, because they're so versatile, their use has just exploded. I'm talking consumer electronics, yeah, like your phone, but also things like life-saving medical devices, incredibly complex car systems, and even the most cutting-edge aerospace and defense tech. Seriously, they are everywhere. All right, so what exactly makes these circuits so bendy? Let's peel back the layers, literally, and take a look at the anatomy of a flex PCB. Think of it like a really sophisticated sandwich. Okay, so you start with a flexible core material. Then you get these super thin layers of copper circuits etched right onto it. After that, you add some insulating layers and you top it all off with protective outer layers called coverlays. Those are basically the flexible version of that green solder mask you see on rigid boards. The real magic here, it all comes down to the materials. First, that core I mentioned, it's made of something called polyimide, which is this amazing, flexible, and super durable polymer. The circuits themselves are made from a special kind of copper. It's rolled or annealed, which makes it way more ductile. That's what lets the board flex over and over again. And for the spots where you need to connect the flex board to something else, they add these little things called stiffeners to create a solid, reliable anchor point. So just how thin are we talking? Get this, some flex boards are just 0.05 millimeters thick. That's thinner than a human hair. It's just mind-bogglingly thin, and that is exactly why they can be packed into the tightest of spaces. It's a truly amazing feat of engineering. But look, making a circuit that can bend is one thing. That's only half the battle. Making sure it stays reliable and durable after bending 1,000 times, that's where the real art of design comes into play. Okay, so here's the crucial thing you need to understand. You know how if you bend a paperclip back and forth, it eventually just snaps? The same thing can happen to the copper circuits in a flex board. It's a process called work hardening, and it is without a doubt the #1 enemy for any flex circuit designer. So, to fight against this, engineers have a whole playbook of special design rules. For example, you'll never see a sharp 90-degree corner or a sudden, abrupt change in the width of a copper line. No way. Instead, they use these smooth, gradual tapers, or even these cool teardrop shapes where a thin line connects to a bigger pad. It's all about distributing that stress so you don't create a weak spot that's just waiting to break. And the cleverness goes even deeper than that. For big areas like power or ground planes, you'd think they'd just use a solid sheet of copper, right?
Wrong! Instead, they use a hexagonal, honeycomb-like pattern. Just like a real honeycomb, this structure is incredibly strong but also flexible. It distributes all that bending stress across tons of different points, keeping everything electrically connected while being way, way more flexible.
All right, so with all this incredible engineering happening, you gotta wonder, where is this technology headed next? Because let me tell you, the innovation is not slowing down. The future is even more flexible. I mean, the pace of innovation here is just accelerating. We're now seeing designs with way more layers, basically creating these complex three-dimensional circuits. Engineers are also integrating these specialized connectors, they're called ZIF connectors, right onto the boards to make assembly way easier. And get this, they're even figuring out how to add shielding to protect sensitive circuits from all kinds of electronic noise, all while keeping the whole thing flexible. But maybe the biggest leap forward, the real game changer? It's bringing high-density interconnect technology, that's HDI, into the world of flex circuits. What does that mean? It means you can pack even more circuits into an even smaller space. We're talking about a whole new level of miniaturization and complexity, but for things that can bend. And that brings us to one last really fascinating question to think about. For basically a century, our electronics have been trapped inside a box, a rectangle. But now that the circuits themselves can bend and twist and fold, what new shapes will technology take? What's next? The possibilities, well, they're truly as flexible as the very circuits that are going to power them.